Right, wouldn't it be great if we just got a radio module or a microprocessor and it did everything what we wanted it to do, straight out of the box? How many times has that happened to us? You've got a radio module, you want to connect a sensor to it, you can connect a sensor and you don't have to do anything. Doesn't happen in the real life. And now that there's over 15 billion connected devices on the internet, and only 8.1 billion people on the planet, you can see that we're sort of led by an IoT technology infrastructure nowadays. So getting the right microprocessor or radio transmitter to do what we want it to do, it makes life easier for everybody. So we're going to talk about customizing firmware on a radio module specifically, because that's what I specialize in. And we're going to have a look at how you can bring your own firmware to a product, or should you use the standard stock firmware. We're going to have a look at some development challenges you'll experience, the firmware challenges, the debugging stage, certification's even worse, and how, if you use a Würth radio, which is blank, or bring your own firmware, how might that help you? Once you've got something, what do you need to do next, the next steps? And the cyber security legislation, testing. Just as a quick rule of thumb, how long do you think it takes you should allow for testing on a radio module compared to your development time? 20%, 10%, 60%? Okay, we're going to find the answer later on. And if I've got time, because this is a shorter presentation than what I was expecting, I can talk about how you might actually implement some cyber resilience using Quantique's crypto example, using one of our radio modules. So, what's the advantage of using standard firmware? Well, it's faster to market for a start. The certification, we use certified modules. That means that when you get one of our radio equipment modules, what's actually certified? The board. The module itself can't be certified directly because you need some way of powering it up. You can't do that just as a module, so it's the board that's certified. But if you follow our examples or application notes or talk to a field applications engineer like myself, we can advise you how to minimize the stress of actually developing your own hardware so it passes easier. The downside is it's not very flexible. So you get one of those Würth radios, you might want it to work with a VOC sensor, a LiDAR. It's not supported. So it's difficult to do, so you have to use a second microprocessor to do that. The downside is this is an IoT device. I'm now powering up 2 microprocessors. My battery life's going to suffer. So it would be great if I could have the flexibility to write my own firmware so it takes the sensor that I want to use and be able to publish it to the cloud. Optimization for your product. Again, I've just mentioned that we're really looking at battery life. That's one of the main criteria, I think, or the sensors that you want to use. So, development challenges. Many of us can see that we're surrounded by different protocols, Zigbee, Bluetooth, Wi-Fi, LoRa, sub-gigahertz as well. It can be quite confusing to choose the right one. And having that in-depth knowledge, as engineers, our bosses seem to think that we know everything. A new standard comes out, Halo, okay, how do we use that? And they expect you to know. So the technical challenges are just being able to keep up to date with how it works, what you need to get it working, can be quite difficult. Then we've got compatibility issues. We're using Bluetooth. It's got to talk to a node device, so it's got to use classic, but everything's moving towards BLE. So we've got that challenge is making sure stuff's backwards compatible. We then get on to the harder stuff. How many of your guys are RF design engineers? Oh, refer to you for answers. Okay, Most of us are not. Most of us are just pure hardware or software guys. So an antenna to us is just a piece of wire, and we solder it on, and hopefully it does the job. But the RF design stage is really sensitive, as you probably can testify. Getting it to work correctly is quite difficult. And if you make slight issues or make small mistakes at the early stages, it can seriously detriment the performance of the radio module. The power supply can have a great impact on this as well. So there's a lot of pitfalls on the hardware that we have to be really careful. So minor layout issues can dramatically reduce the range and performance. Believe it or not, I've seen antennas on the PCB and then they put a ground plane underneath it. Or they put metal screws next to it. It does happen. So the level of expertise on the RF is another barrier to creating your own modules. We need to do some proper shielding and grounding and impedance matching. The length of the traces has to be correct. So it can be quite difficult. So it's easier to use a module that's already got built-in antenna or some reference design. Then we come on to the firmware, which as engineers we all like to add our own little bit of spice to any project. The bit that I can say I did that. So customizing the firmware is powerful but very time consuming. And then you get a balance of performance and efficiency can be quite tricky. Long-term development cycles, if you're not using the right tools or libraries, can be difficult. And project creepage. How many of us have worked on a project and someone says, can we just add this to it? It shouldn't take long. It should only take a couple of hours. Or we've done that in the past. Can we just add this? So what I would say is, if you're going to design your own firmware or bring your own firmware to it, have a list. Must have, nice to have. And set your project out from day one, what is going to be on there, and stick to it. So, debugging wireless systems is incredibly hard. It's often an intermittent problem because we're not always transmitting, so you can't always see what's happening. You need specialized equipment. So RF can't be really seen without specialized equipment, so you need that. So you need expensive spectrum analyzers, protocol sniffers, things like that. So you both need an embedded hardware specialist and an RF guy now, which not every company has. It's very difficult. So part of the Würth is we try and give you support. We're not experts in RF at local level, but we do have a branch in Munich that specialises in antenna matching and able to help you with that. So getting the RF and the debugging right is quite difficult, and what we do is make evaluation boards like this one, which should speed up your development of your firmware, prove that it works right. You can test the range, make sure it does everything right. So it's a really good starting point to have an evaluation board, and this is why we make them. So lack of in-house experience with RF, I've mentioned before. You really need a strong knowledge of RF systems. So how are you going to transmit data? How long you can transmit data? Has anyone heard of the Polite Spectrum Authority? Oh, Polite Spectrum Access. So we'll look at that. So there's certain rules you have to abide by. So you're then looking at increasing dependency on external consultants to come in and design your antennas, make sure you're doing everything right. Certification to a standard, whether or not you're using Zigbee, Bluetooth, that can be quite expensive. So time to market pressures. So if you're developing your own firmware, your boss is saying, I want to launch this at the show in September. I need the firmware finished. I need to get through the EMC testing. I need the radio certificate for it. How quickly can I get this through? So it does put a lot of pressure on the design team to try and push this through, and things get missed. Any delays in development can seriously hamper the product lifecycle or getting it to market, and it has a ripple down effect. Particularly for startups and small teams, they don't have the luxury of this, so things get pushed to one side, and it all happens, and therefore your product doesn't really fulfill what it's supposed to. It's not going to succeed in the market. So we then come on to the bottleneck certification. Taking something through the radio testing can be quite expensive. So it takes a lot of time because we have to test at every degree, angle, vertical, horizontal, test firmware in here to transmit at the full power all the time would have to be written into there. So although you've got the radio protocol working as you expected it, you would have to then write a test procedure, or else if you're only transmitting for 1% in an hour, 36 seconds, and you're testing 360 degrees in horizontal and vertical polarization, your Eurofins or Element test house will be very grateful because they're going to earn a lot of money out of you guys. So one advantage of using one of our modules, again, is if you're using a standard radio protocol or, like Bluetooth, Wi-Fi, as long as you're not altering the radio performance on there, you can actually refer back to our testing standards, which might make it easier. The only limitation I would say is not all countries will accept you writing custom firmware, even though you can backwardly say it's been tested before. So it can be difficult. So even with a certified module, it doesn't automatically guarantee you're going to pass, because you might be altering the power levels of the RF transmitter, the duty cycle of it. Okay, you might not conform to Bluetooth standards. But it's certainly easier if you're using standard compliant physical layers like Bluetooth, Wi-Fi, LoRa, and it's implemented in the actual device. So it does make it easier in that respect. So non-standard firmwares or custom PHYs or custom protocols, they will be more difficult to get through the standards. So you're better off sticking to a well-known one, which you can research and implement correctly. Some countries like Japan, even if you took a standard firmware from Würth, if we presumably gave it you, and said, just add this sensor to it, would have to be retested from start to finish. Just by modifying it the slightest amount. So it's not always easy. And to complicate it, there's no worldwide structure for this. There's no worldwide testing that will cover you in any country. As you can see from this map, different colours, different rules, different standards, different harmonised standards within them. So it can be quite difficult. So we can help you work out which radio modules, which frequencies, which duty cycles you're allowed to do. And that's all from the technical team at Würth. So here's some examples of some radio, we call them short-range devices. The advantage of that is because they're not intended to transmit a long distance, the rules on them are slightly more relaxed than if you were doing a 5-watt or a 10-watt transmitter. So you can see from the duty cycles of most of these, they're less than 1%. Or you're allowed to transmit 100 messages within the hour, which can equate to a 2.7% duty cycle. But we're very limited on which bands you can transmit all the time. So on these audio devices, because you need audio all the time going into your headphones, they can transmit all the time, makes sense. But for IoT, we're looking at very limited duty cycles. So building one from Würth, how can the radio module? Well, you've got technical support from an FAE. We've got the application notes. We've got the design sheets. We've got stock firmware on GitHub repository. So we tend to give you some examples on how to implement the radio stacks. We can help you if you don't know how to design the antenna. We do the antenna matching service. The eval boards are readily available. And because we've got the pre-certified stacks, Bluetooth Classic, BLE, Wi-Fi, LoRa, and many sub-gigahertz ones, it might make it easier. Not absolute certainty you'll pass, because if you've exceeded the duty cycles or the frequency or the power levels, it can affect it. But you're more likely to make it easier because we've taken into account the power supply requirements for the chip. We know the antenna is going to perform correctly. We're not going to have any spurious RF that's going to affect other equipment. So key features, we do have pre-certified modules, so if you can use a stock firmware, I recommend that you do. It makes life easier. But if you have to use your own custom firmware, because the modules already achieve that level of standard, there's no reason why if you implement your own firmware correctly, it shouldn't meet that standard. The advantage of, again, lower power consumption. If you don't have to use a separate processor, you can actually achieve a better sleep standard than some of our standard modules, just because we keep certain things awake just because we want an interrupt on something. You can have integrated or external antennas can be used. So many of our modules use something called a smart antenna. So most of the boards have an internal antenna already designed for you, so it's really easy to use. If you want to use an external antenna, it's just a simple capacitor, a little pi filter, then to your external antenna. Würth's committed to always being able to supply you a 10-year from the date of issue. So on most products that we supply, if we supply you today, you can be guaranteed that we're going to supply it in 10 years. However, on silicon, we are dependent on our partnerships we work with. If a factory, we use ST chips, typically. If the factory burnt down tomorrow, it might impact on us. Okay. However, we do work with companies like Expressive, but we manufacture our chips in Germany, so it might not be such a big impact, and you've got the quality of the parts being manufactured in Germany, so in Trier. So product lifespan's really important to our customers. They want to know that they don't have to do a respin or a PCB, and this is what we're trying to aim for, long life. So it's easier to develop your own firmware without having the hardware worries if you use an evaluation board, so it can speed it up. So when we come on to development environments, so it can be quite difficult. How many of you are actually software guys? Firmware? Okay. So a lot of our microprocessors support the Zephyr operating system, which I'm led to believe, I'm not a software guy, so please correct me if I'm wrong, it's really geared for multiple stacks. It's really probably the next generation from C++. So it is a bit more complex, and it's a very steep learning curve. So what we tend to find is a lot of customers using platform I/O. Arduino based, really, really easy. But what I would caution against is using the Arduino environments is absolutely fine, and I'll hold my hand up, I use them. But we have to be careful because we don't know the full APIs behind there, and we tend to leave a little bit of code in that we might not use. We'll add a library into a project, and we'll leave it there. We don't tidy up. This puts the ability to someone hack that bit of firmware, so wherever possible, if you're not using a library or a little bit of code, you need to remove it. We also support the Expressive IDF environment, which is a bit more professional based. So if you can move on to that one, maybe a better choice. and that also supports Zephyr as well. So the Nordic chipset that we use, the NRF52840s, really good for Bluetooth and also Zigbee. So the web SDK from Nordic does have really great examples on how to get that working on our devices. So really good support from those guys. So let's go through this checklist. So we need to define what project's going to have. Does it really need to have this extra function that the boss has just walked in with? So tie it down. If you can get away with selecting your hardware early, so I want to use this protocol, or I don't want to use, I want to use Bluetooth as opposed to Bluetooth Classic, it's better to tie that in first. Then decide, really, can I get away with this standard stock firmware? If you can, it's probably the quickest way to market and the lowest amount of headaches. But ultimately, if you can't do that and you have to build your own firmware or bring your own firmware, be assured that we're here to help as much as we can. Confirm which markets it's going into and what standards you have to achieve for the certification. Also, plan for the security and update strategy. The Radio Equipment Directive comes into force from August, and how many is hopefully just burying his heads in the sand and hoping it goes away? A lot of companies haven't done anything, they're just going to wait and see a moment, and I'm finding that a lot. It's not going to go away, we need to do something about this Cyber Resilience Act. So we can help you with that, and hopefully some of you guys might have talked to Quote Quantique at the moment. Has anyone spoken to them? No. Okay. Setting aside for testing and resourcing the radio testing. So going back to how long you should leave for testing the radio, it's actually 50%. You should allow 50% just on your firmware. So it's a very long portion of time. So getting started, how do I do it? Well, I keep pushing the eval kits, and I've left a link for the Würth evaluation kits, and most of these we give you for free. So if it's there, it's a resource that you're more than welcome to use. We also recommend using Red Expert, and we also do live demonstrations as well, and come in to talk to you how you want to implement it in more in depth. We do lunch and learns where you should get free pizza, and we give you free talks. Has anyone attended the lunch and learn? You have. It's good pizza, isn't it? So we do these webinars as well. So we have a lot of webinars. We're hosting some with some security partners later on this year. And we've got these application notes, how to lay a board up, what to avoid, how to conform to certain standards, what you might need to know. And then you can always email us for technical support. How many of you have used the web page and seen the little pop-up in the corner from Würth? So that guy is not a chat bot, it's not a chat AI. It's an actual person in our office, and we do something called Chasing the Sun. So there's 24-hour technical support to an actual person. We've got a nice little user guide on product guide. Tells you which products are allowed in which countries, what frequencies are available, how much you should be able to transmit, and some good examples on how to use them. And we do an antenna matching service. The antenna matching service is done in our office in Munich. It's free as long as you're using Würth parts. So if you use our antenna, at least, we can help you. And what I would say is the best thing about that is if you can leave your project until you've designed the case, everything else, because your body, being next to your body, being near a case can affect the actual radio performance, and we can optimize it best if it's more closely towards its end stage. But we can make recommendations of what you should do on your PCB, like adding a pi filter on the front end so we can match it easily. Würth GitHub contains many firmware examples for microprocessors from ST, Microchip, expressive. We've got all the drivers there for the radio modules, how to talk to them. We've got some great stock firmware what you can load onto your PC and talk to it directly through USB without having to commit to hardware first off. We've got the LT Spice libraries. We've got the cyber resilient seminars coming up, component libraries. We've got an application, even getting it to work with your phone. We've given you the free source code for that. So if you've got to make a Bluetooth device to connect to an iOS phone or an Android phone, we give you example code on how you can do that with our modules. That's using our stock firmware, I'll be honest. Not so much the bring your own. We also supply the Adrastria SDK, that's our mobile service. And we've got really great support from Sony who populate your GitHub repository with a lot of examples. So I know a little, the STM32s are a really well respected and well used device. So we've got many examples using that chipset. So testing, like I said, you need to set aside 50% of your time for development and testing in embedded systems. It's sad but true, as you can see. We should remove any dead code, as I've mentioned before, and any libraries that we're not using. It presents a security risk and a maintenance risk. And we also need to keep conscious of anything that's coming downstream. So how do we update these devices in the long term? Any devices that are out there at the moment, you have to do a risk assessment on them for the Cyber Resilience Act, particularly if you're carrying on still selling them. So even if it's an old product, it still falls under the legislation. Mentioning the legislation, it can be quite daunting. We can go into much more detail at a later date, but just be aware all these apply to you. And we have partners up with Crypto Quantique, which basically, I don't know if anyone's been to their presentation, but you get an IoT device typically, and it connects to a Wi-Fi router. It then passes through your router and goes directly to your service provider. This is the standard model. So when we're using Quark Link security, it's exactly the same process. However, Quark Link actually sits on the cloud and it's responsible for all the connections. So it makes sure your device is cyber resilient, compliant. It digitally signs your updates. It allows it to connect to a network. It provisions it. So it's a really good solution. If you've not used it, they do give you 50 free devices on their network for you to try. So it's well recommended. So as you look from the beginning, we normally select a micro. We then do some firmware update. We stick it in a nice plastic box. We connect it to the cloud, and then we get an application. So we've got a root of trust set up, how to install the software. Secure provisioning, connecting it to the Wi-Fi, making sure no one can hack the device. One example on hacking at the moment is a Bluetooth device. I've got one of our devices. I can actually get everyone's iPhone here to just basically get in a restart loop just by hacking the Bluetooth. It's a new security feature that they must have added by accident. So getting updates and keeping security is not going away, as I said before. So having a partnership that can really help you do that and maintain it for you might be a benefit, especially if you're doing your own firmware. So I highly recommend checking these guys out. And we do secure on booting and certificate and device management. I've left the link. There's a nice video to set this up on the ESP32s. I know a lot of you guys use this chip. So there is a 10-minute video, how to set one up. You can use this on our Stefano or Athosi boards and get that to work, and therefore makes it easier. And I've come in bang on time. Thanks very much. Any questions?